Okay, so the type 2 also talks about what? The unknown what? Number and the modular operation. I've spoken about this one already. So we are done with that of what? The modular number, and we are now going to tackle this type 2, which is what? When the number under the modular what? Operation is not known. What do we do? Are we okay? So that one we don't have much steps. That one too is very what? Simple. That one we are only going to what? Verify. We are going to pick what? Numbers and we what? Verify. Since we know the modular number, we'll be using the modular number in what? Verifying. Please, are we getting that? So what do we do there? Let's take an example, then I use the example to what? Explain. Are we okay? So the first example says what? Example 1. Example 1 says what? If 7x is equal to 3 mod 6, we have to find x. So solution. So here what do we do? You see, we have 7x is equal to 3 in mode what? 6. So 7 by what number in mode 6 will get you 3. That is what they are referring to. So we can write this one in the other way. So this implies that we have what? 7x in mode 6, which is equal to R3. Are we getting that? So 7x mode 6 is equal to 3. So 7 by what number? Mode 6 will get you 3. And this is what we do. Here we're also going to be using, since now the modular number is known, we use the possible remainders for what? The modular number. Then we use that one in verifying. Are we getting that? So we use those numbers, we substitute each of the numbers here to verify the one that will give us what? 3. So the first thing we write is what? The possible remainders for what? The modulo 6. Are we getting that? So, okay. So possible remainders for what? The mode 6. And they are what? Let me write what? For the first example, let me write what? Possible remainders of mode 6. So we have 0, 1, 2, 3, 4, 5. That is that. So that is, we have 0, 1, 2, 3, 4, up to what? 5. These are the possible remainders. Since the modular number is what? No. Then we put what? Or we substitute each of the remainders inside what? The statement to verify. So what we were doing for when the modular number is not known, we were taking this one, the difference, and we were using the factors. Please, are we getting that? But since what? Now the modular number is known, whenever you want to find what? The number, what do? We find what? The possible remainders of the modular number, or the possible remainders of what? The modulo. Then we take what? Each of the what? Remainders in verifying, or we put them into the statement to verify. Are we getting that? Or to check the one that will make the statement true. Are we okay? So we pick the first one. So here we say what? When we have to find what? X. So we say x is equal to what? 0. Then this implies that it will get to be 7 into bracket 0 in mode what? Mode 6. And that one is getting us for 0 in mode 6. And it's equal to. So if I have 0 in mode 6, the answer is what? 0, because what? 0 is what? Less than that of what? The mode number. Or when what? How many 6 can we get from mode 0? That is what? 0. Then what is left? The 0. Then we also take when x x is equal to what? 1. Then that one too gives us what? 7 into bracket 1 mod 6. Then that one too gives us what? 7 mod 6. And I hope you said that one is 1, right? Then when what? X is equal to 2. This one too gives us what? 7 into bracket 2. Then mod what? 6. And that one to 72 is what? 14. And mode 6 is equal to. So you can pick 14 divided by 6, and that one we are going to get what? 2. 2, because yeah, you know that. So when x is equal to 3, we have 7 into bracket 3 in mode 6, and that one is 7, 3, 21 in mode what? 6, which is equal to, then 3, 6, 18, 21, 18, so what is left? That is 3. Okay, so we have 3, and I think you can wave this. Then when x is equal to 4, this implies that we will have 7 into bracket 4 mod 6, which is equal to 7 for 28 in mod 6. And this one too is getting us what? So 6. 6 for 24. So this one is getting us what? 4. Okay. Then we proceed. The next one says what? When n is equal to 5. Is it 5? Yeah. So this implies that I'll have 7 into bracket 5 in mode 6, which is equal to 35 in mode 6. Then this one gives us what? 6, 5 is what? 30. Then what is left? 5. Or you can also put 35 divided by the 6. Then you convert. So the remainder is 5. You can see that. Then we now verify the possible x values that makes the statement true. We have the first one here. That is this one. And the remaining ones are not. So we can say what? Therefore, x is equal to what? 3. So it's only when x is equal to 3 that we get what? 3. Or it's only x being equal to 3 makes the statement what? True. Are you getting that? So that is the possible value for x is what? 3. So when we put it inside here, let's imagine here, we will get what? 3, 7, 21. And 21 mod 6 is equal to what? 3. That is that. So now, let's now take what? The next example, that is example number 2. Example number 2 also says, we have to solve x plus 9 in mode 5, this is equal to 3. So solve x plus 9 mode 5 equal to 3. So here, what do we do? So I'm giving what? This. X plus 9 mode 5 is equal to what? This. And this one is already in what? The form that we used to what? Write. Is that not it? And we have to find what? X. So that one to the mode or the modular number is given. So we write the possible remainders. Are you getting that? So we have the mode 5, which is equal to the possible remainder 0, 1, 2, 3, then what? 4. Then what do? Then we substitute each of the remainders inside here. So I will say when x is equal to what? 0. So this implies I'll have 0 plus what? The 9 in mode what? Mode 5 equal to 9 in mode 5. And 9 mode 5 will get us what? 4. Okay, that is that. Then when our x is equal to, let's say, the 1. So that one too, this implies that I'll have 1 plus what? 9 mode 5, which is equal to. Then that is 1 here. So I'll have 10 mode 5. And this one will get me 0. Then when x is equal to 2, so this implies I'll have 2 plus what? 9 in mode 5. And this one will get us 11 in mode 5. So 11 in mode 5 is equal to 1. Please, are we here? So I think that is that for that one too. So I think that is that for that one too. Okay, then the next one, when x is equal to 3, then this implies that I'll have what? 3 plus 9 in mode 5. So that one too is getting us 12 in mode 5. And it's equal to 2, right? Okay. Then when x is equal to 4, which is the last one. Okay, this implies I'll have 4 plus 9 in mode 5. So this one gets me 13 in mode 5. So that one too gets me what? 3. So since we are done, and now what? This one is getting us 4, 0, 1, 2, and we are having the 3 here. It's only 4. So therefore, x is equal to 4. Please, are we getting that? Isn't this simple? Okay. Now, what says example number 3? Okay, in example number 3, we have to find the value of x in. Find the value of x in 5 squared plus x squared, which is equal to 2 in mode 4. So what do we do? So this one is not in the way that we used to solve. So what do we do? I can put this implies, can you write that one for me? Write it in the way that we used to solve, so that it will be equating what? The remainder. And I hope you're able to get this. 5 squared plus x squared. Then mode 4 is equal to 2. Were you able to write this? Okay. Okay. You can pause the video and you try. Are you getting that? Okay, let's proceed. So now this one is getting me this. And I can work this, or you can leave it this way. 5 squared, then you just put the square over there, you work. So since the modular number is given, now I can write what? Mode 4, which is equal to the possible remainder 0, 1, 2, then 3. Are we getting that? So then we put each of the digits inside here. Are we getting that? So you solve that one, and I will not solve. I'm only going to write the answer. So what value of x when put here? We'll get that what? 2. And it should be from this. Are we okay? So what do? We take the 0 when x is equal to 0, then we put them here, then we solve. Are we okay? Okay. So somebody can even, before writing this one, can write this implies that 5 squared, then the person will simplify to get what? 25 plus x squared mode. They are the same. You can leave it like this. Then you put the 5 square will be there, then are we getting that? Okay. So after you are done solving, you are going to get x to be equal to 1 or or 3. So you are going to get x to be equal to 1 or x to be equal to 3. These are the possible answers you are going to get for what? X after solving. And I hope you're able to get that, right? Oh, okay. Oh, okay. So that is that. So now can we now move on to example number 4? Example number 4. Is it my people? I'm getting exhausted. So after solving, you are going to get the values for x to be 1 or what? 3. So x will be equal to, it's only 1 and 3, that will make the statement or 3. That will make the statement, this statement or 3. So after you are done solving, you are supposed to get what? 1 or 3. Let's now move on to example number 4. Example number 4, and that one will be our last example for the day. Okay, so example number 4, I want to write that one here. So example number 4. So you have to find the two sets of 34, which is equal to x in mode 6. So we know this one too is very simple. Always we said what? We have two poles. You'll be given what? The remainder, the number, and you'll be asked to find what? The modulo number. Or you'll be given what? The remainder, the modulo number, and you'll be asked to find what? The number. But here's the case now, we are asked to find what? The remainder. And that is what we've been doing what? Previously. Do we get that? Okay, so we said this one, we have other way of writing this, and I think you can write that, right? So you pause the video, then you write that one, and you'll see it very what? Simple. Can you do that for me? Okay, and I hope after doing that you're able to get this. 34 in mode 6 is equal to x, right? Okay, let me see my hands of those who are able to get that. Okay, that is good. Let's proceed. And they are saying that 34 mod 6 is equal to what? And that is the value of what? X, right? So 34 in mod 6. What do we do? So we put the 34, then divided by 6, right? Then we convert to what? Mixed fraction. And we are having a 5 whole number, 2 on 3. Then what do we do? The denominator here is 3, and we are supposed to get what? 6. So what do? We multiply here by 2, then here 2 by 2. So now we get 5 whole number, 4 on 6. Then now the remainder is what? The 4. So meaning 34 in mode 6 is equal to 4. So meaning when 6 goes into 34, there will be 4 what? Left. So we can now say therefore x is equal to the 4. And I think that is that. Are we okay? I wasn't supposed to solve something of this sort here because we are into the two types. and you'll be able to write this one in this form. I think everything is okay, right? So on that note, we're gonna end here. See you next time. Bye bye.